Hi, my name is Vijay Chandu. I'm from CSAML bench and I'm going to explain about operation of PNP transistor in active region. So let's start with the introduction. A transistor is a three-terminal electronic device where small current at one terminal is used to control large current at other terminals. Transistors are mainly used for the amplification of electronic signals. Transistors come with three terminals called emitter, base, and collector, which are used for the external connection with electronic circuits. Transistors were created with the intention of providing cheap electronics. They are available individually. However, most of the time they are packed together in integrated circuits, which are then used for the development of processors, computer memory chips, and complex ICs. Transistors that come in NPN and PNP configurations are nothing but the combinations of two diodes joined back to back, as you can see in this picture here, combined with P, N, and P. In NPN transistor, current flows from collector to emitter, while in PNP, current flows from emitter to collector. Active mode is used for amplification of electronic signals where small current at the base terminal is being amplified at the collector terminal. The base terminal is responsible for the transistor action, which controls the number of main charge carriers, which are electrons in case of NPN transistor and holes in case of PNP transistor, flowing through it and draws a small current when a proper bias voltage is applied. Next, PNP transistor in active region. Transistors that come in NPN and PNP configurations are nothing but the combination of two diodes joined back to back. In NPN transistor, current flows from collector to emitter, while in PNP, current flows from emitter to collector. The current directions and voltage polarities are always opposite in both transistors. Suppose if a current is flowing in a clockwise direction in NPN transistor and comes with positive polarity at the base terminal, it will flow in an anti-clockwise direction in PMP transistor where voltage polarity becomes negative. PN junction formed between two semiconductor materials is building block of the transistor. When PN junction is formed, major charge carriers in N region or electrons cross the junction, reach the P region where they combine with holes. Similarly, major charge carriers in P region are holes which are positively charged, cross the junction and reach the N region where they recombine with electrons. The diffusion of electrons and holes depends on biasing voltage applied across the junction. The voltage is said to have forward biased when P region is connected with positive terminal of the battery and N is connected with the negative terminal of the battery. So here in this diagram we can see here this P is the emitter and the second one is the collector. Here N is the base. So this is the circuit diagram. Under the forward bias condition, holes and electrons can easily cross the junction and maintain a current across the junction. When this diffusion occurs, it will generate the region across the junction, which is depleted with the major charge carriers. This region is known as depletion region. So here it occurs the depletion region where it becomes thinner, so it is easy to flow the current. As long as the forward bias voltage is applied, current flows across the junction. Diffusion of holes and electrons create an electric field within the junction. This electric field resists the further diffusion of charge carriers. As said earlier, transistor comes with two PN junctions where one junction is forward biased and other is reverse biased. Here I conclude my PPT. Thank you.